Okay, now we get to question 3. Question 3 looks like it's the projectile motion question. Projectile motion and this is usually the standard format for physics exams. You start with a Newton question, then your vertical projection, then your momentum, then your Doppler effect, your energy question, then your Doppler effect question, then electricity, then your static electricity question. After static electricity, your AC/DC motor generators question, and then your last question is usually your photoelectric effect. So that's the normal standard for a question paper. Let's go then to question 3, which is our vertical projection. A ball is thrown vertically upwards at a velocity of 4 meters per second from a roof of a building with a height 10 meters. The ball strikes the ground and rebounds to a height of 3 meters. Ignore the effect of friction. So obviously talking about air friction. Calculate the time taken for the ball to reach its maximum height. So always, just the moment you remember maximum height, or maximum height, that's where velocity is 0. So let's see if the student know that. Okay, your future velocity is 0. He chose -4 as his initial velocity, and so his upwards is negative, his downwards is positive. Beautiful. The time taken for the ball to reach its maximum height, this is beautifully done. I have my initial velocity is 4 meters and negative because it's upwards. My final velocity is 0 because at the maximum height I reached 0. My acceleration then very important. Your acceleration is downwards. The ball is thrown upwards. So it doesn't matter what sign you chose here, as long as these two have different signs, you'll get the correct answer. And the answer then looks more or less correct. I'm not going to work it out. Is 0.48 seconds. Well done, student. Question 3.2. The maximum height that the ball reaches above the ground. Okay, so all we need to do now is work out how high it went above here. Again, beautifully answered. My future velocity is 0, initial velocity -2 squared. 2 times a. Again, these two signs have to be different. Then delta y is then the displacement that the ball has, and this is the displacement. That's how high it goes from here to there. But the question was, the ball reaches above the ground. So there's a 10 meters that has to be added, and so it's 10.82 in total. Excellent. Again, I'm not going to calculate this. This looks accurate. Because 2 times, yeah, definitely looks accurate. I won't go further into that. Okay, next question. The ball strikes the ground 1.96 seconds after it was thrown and remains in contact with the ground for 0.2 seconds before it bounces back upwards. Sketch a graph, not to scale, of position versus time representing the entire motion of the ball. Use the ground as 0 reference. Okay. Now what that just means is that if the ground is 0 reference, then if I draw my graph, then I must start at 10 meters, because I must start 10 meters above the ground, because the ground must be 0 reference. Okay, hopefully that made sense. Let's look at the student attempt. Okay, it appears the student didn't do this question. I see he immediately goes to question 4. Okay, so let me just answer that one. So the ground is 0 reference. Again, guys, please don't not attempt a question, because there's no way of improving your understanding. But anyway, I'll still draw that. 0 reference would then be on the ground, and since something can't fall lower than the ground, since this is then the ground, something can't fall lower than the ground, it would mean that we will never draw something on the negative side here, just for this specific question. Usually we use the starting position as 0 reference, and then throwing it up, then the moment I get here I'll start going negative. But since I'm starting at 10 meters, I'm going to start at 10 meters up there, then he throws it up, it reaches the ground, it is a parabola shape. Okay, because it's a quadratic function, we have that change in y is equal to is it change in y is equal to v initial velocity t squared plus a half a, or g in this case, t. Sorry, this one isn't squared, this one is squared. T squared. There's the formula. So you can see t is my horizontal axis, so and y, it could have been changed in x as well if you prefer using that. But then you can see t squared means it's a quadratic function. And so this position here is just my y-axis. And yeah, then here it remains in contact for a little bit of time. It remains in contact with the floor, and then let's just see what they wanted answered. We must give the height from which the ball was thrown, yes. The maximum height that the ball reaches above the ground, yes. The height reached by the ball after bouncing, and the time the ball strikes the ground, yes. The contact time of the ball with the ground. So then it's in contact there, and then we must reach a height again. So just to know how high it bounces back up, I'll have to do a calculation. So according to them here, the height reached by the ball after bouncing. I'm trying to work out if we have enough information to answer that question, because I do need initial velocity. Counting before bouncing. Okay. So, and rebounds to a height of 3 meters. Oh, okay, cool. Okay, so they told me how high it bounced. Okay, so 3 meters is roughly, doesn't have to be on scale, is roughly there. And so I just bounce back up. Again, my upward bounce will have a slight parabola shape. Okay, or perfect parabola shape, but just to be seen. So this we worked out was at a height of 10,82 meters. Okay, sorry for the bad writing. And this happens at time 1, was it 0,48? We worked it out. Time taken to reach the maximum height. Okay, it takes 1.09 seconds to reach the ground. So this one is 1,09. Okay, 1.09. Then 0.02 seconds later, so this must be 1.11. If I add 0.02 to that, and then, is that correct? 0.02, oh, 0.2, so it's not 0.09 but 0.29. 0.29, and then I just can't recall, I think it was 0.48. 0.48 was the calculation. 0.48, yes. So this time here was 0,48. Excellent. So hopefully that's not too ugly drawn. Okay, excellent. And do we need to show the time it takes for its second bounce? Okay, the time the ball strikes the ground, the contact time of the ball with them, and the height reached. No, it's not necessary. But if we needed to, we could have calculated the time from 0 to 3 meters using the exact same method as we did before. This time it's just distance, so we could have used, yes, probably this formula, exactly this formula of how long it would have taken me to reach a height of 3 meters, or just use, what else do we have? Actually, we can't use this one because we don't have initial velocity, so this one won't work. We have final velocity 0, so we have final velocity squared is initial velocity. No, that one won't work. Final velocity is equal to initial velocity plus a half times. No, that one won't work. So let's quickly look at our formula sheet here. Final, we don't have initial velocity, so which one don't have initial velocity? Why does everyone use initial velocity? Can't we work out just delta x? No. I suppose we can just work out initial velocity. Final velocity delta x. And the time taken. Okay. So suppose we could just work out the time and initial. We don't have that. This one we can just work out. Future velocity is 0, initial velocity is unknown, and then 2 times 9.8 times 3. This is then this side, so if I take it to the other side, to get, it should have been negative 9.8, and taken to the other side, which would be positive. And then I get my initial velocity is the square root of that, which is 7.66. And then if I wanted to work out time, I would take 7.66 is that initial velocity upwards is positive because I used negative 9.8, downwards is negative. These two have two different signs. Okay, it doesn't really matter which one I use, up or down, as long as I remember that these two have different signs. So if I keep this one positive, it meant it was negative on this side. So it was negative upwards. This is downwards, so that's positive. So divided by 9.8 gives me then the time. That would be the time there. It wasn't asked, but yeah, you could have calculated it. Okay, and that was question 3. A short question counting 13 marks.